can create matrix variables. If you want to put the values in square brackets, we'll see that that's a combination of the methods that you use to create row vectors and column vectors. And that is that you can separate the values within the rows with either blanks or commas, and you can separate the rows with semicolons. You can use any method that you could use to create a row vector in order to get the values in each row. For example, you could use the colon operator. Here's an example in which I'm creating a matrix variable mate that has the values 1, 2, 3, created by the colon operator in the first row, and 6, 11, negative 2 in the second row. One thing that's very important is that you always have to have the same number of values in every row of a matrix. If you try to do something else, you'll simply get an error message. There are many functions that can be used to create matrices, many built-in functions. So for example, the rand function, which creates random real numbers in the range from 0 to 1, that can be used to create matrices of random real numbers. There are two ways you can call it. If you pass one argument, an integer n, it will create an n by n matrix of the random real numbers. And if you instead pass two arguments, then you're creating an m by m matrix of random real numbers. The randi function can also be used to create matrices of random integers. Remember that that's called in a slightly different way from the rand function. So you can pass the range of values that you want for your random integers and then the dimensions of the matrix. So this will give us an m by m matrix of random integers in the range that we specify. There are also functions zeros to create a matrix of all zeros and ones to create a matrix of all ones, and they can be called basically the same way as rand. In other words, you can pass one argument, which gives you an n by n matrix of all zeros or ones, or you can pass two arguments, which are the dimensions. So note that we have functions to create matrices of all zeros and ones, but that's it. There's no function to create matrices of all twos or 13s or whatever, just zeros and ones. Once you have a matrix, you need to be able to refer to an element in the matrix. And the way you do that is you give the name of the matrix variable, followed by, in parentheses, the index of the row, and then the index of the column. So here's our matrix variable mate again. If I say mate in parentheses 2, 1, that means I'm referring to the second row, first column. So the element that's in the second row, first column, stores the number 6. When you do this, you always refer to the row index first and then the column index. This is called subscripted indexing, where you're giving the subscripts of first the row and then the column. You can also refer to subsets of a matrix. So for example, if you want to refer to the entire mth row in a matrix variable mate, you could say mate parentheses m comma colon. So the colon there for the column says all of the columns. So all of the columns within the mth row, or in other words, the entire mth row, however long that is. You can also use just the colon to refer to all rows. So if I say mate colon comma n, that says all rows, but the nth column. So in other words, the entire nth column. So that's kind of a shortcut to be able to refer to an entire row or column. Another method that you can use for indexing in order to refer to the last row or the last column is to use a built-in thing called end. End refers to the last. So if I say mate end comma m, that means the last row, but the mth value. So the mth value in the last row, whatever the last row is. You could also use that for a column index. Once you can refer to an individual element in a matrix or a subset of a matrix, then you could modify that by assigning something of the same dimensions. Another way that you can index into a matrix is to use what's called linear indexing, and that means using only one index. If you do that, then MATLAB basically unwinds the matrix column by column. This is not generally recommended. It's usually better programming style to use subscripted indexing to refer to both the row and the column indices. There are several built-in functions in MATLAB that allow you to determine the dimensions of a vector or a matrix. The length function, for example, length of a vector returns the number of elements in a vector. Length of a matrix is a little different. What that does is it returns the larger dimension, either the row or the column for a matrix. So it only returns one value, whichever is larger, the number of rows or the number of columns. The size function will return the number of rows and columns for a vector or a matrix. Since the size function actually returns two things, and this is very important, you want to be able to capture both of the values that the function returns in an assignment statement. So if I say size of a matrix, that's going to return two things. First, the number of rows, and then the number of columns in the matrix. So if I put that in an assignment statement that has two variables in square brackets on the left of the assignment, what that does is that captures the first value that the size function returns in the first variable r, and it captures the second value that the size function returns in the second variable c. So now I have the number of rows stored in a variable r and the number of columns stored in a variable c. Another function is the numL function. That returns the total number of elements for either a vector or a matrix. So for a vector, that's the same as the length function. For a matrix, it's the product, the number of rows times the number of columns. It's very important to be general in program. You should not normally assume that you know the dimensions of a vector or matrix. So typically what you would do is use the length function or numL to find the number of elements or the length of a vector. And you would use size to find the size, the dimensions of a matrix. And again, it's usually useful to store the two values that you get from the size function in variables. There are many functions that change the dimensions of a matrix. Reshape will take a matrix and reshape it into any other format that has the same number of elements as the original matrix. So for example, if I had a 3 by 4 matrix, I could reshape that as a 4 by 3 matrix or a 1 by 12 matrix, which is a vector, etc. So anything that has the same number of elements. Rot 90 will rotate a matrix 90 degrees counterclockwise. Flip LR will flip the columns of a matrix from left to right. Flip UD will flip the rows of a matrix up to down. And the repmate function is interesting. You pass three arguments to it. First the matrix, and then m comma n. What that does is that replicates the matrix. So it takes the matrix mate and it creates an m by n matrix of that matrix. So in other words, it copies it over and over again, so you get an m by n replication of the matrix.